Welcome everyone for next class or second class of the pressure. Now today's we'll continue from the last class related to the explanation of liquid pressure. And at the beginning, I'd like to show you a video related to the liquid pressure at first, and then we'll continue through the slides. Have a look once.
Laws of liquid pressure.
Are you looking
Pressure
this?
at a point inside the liquid increases with increase in depth from the free surface of the liquid. Increases with the increase in the density of the liquid. Is same in all directions about a given point within the liquid. Is same at all points in a horizontal plane at a given depth. Experiments to prove laws of liquid pressure. To prove that pressure at a point inside the liquid increases with increase in depth from the free surface of the liquid, take a thin sheet of rubber from a rubber balloon. Stretch it over the mouth of the thistle funnel having a short stem. Connect the thistle funnel by means of a rubber tube to a U-tube mounted on a vertical wooden board provided with a graduated scale. Fill the U-tube with a colored liquid. We observe that level of the colored liquid is the same in both the limbs of the U-tube. Take a tall cylinder and fill it with water. Now lower the piston funnel to a point P inside the cylinder as shown here. Record the difference in levels of liquid columns in the limbs of the U-tube. This difference is equivalent to the pressure exerted by water at the point P. Now lower the piston funnel to a point Q. Again, record the difference in levels of liquid columns in the U-tube. This difference is equivalent to the pressure exerted by water at the point Q. What do you observe? The difference in levels of liquid columns in the U-tube is more in the second case. That is, the pressure at point Q is more than that at point P. Thus, we can conclude that the pressure at a point inside the liquid increases with increase in depth from the free surface of the liquid. To prove that pressure at a point inside a liquid increases with increase in density of the liquid. Observe the difference in levels of liquid columns in the U-tube when the thistle funnel is dipped in water, glycerin, and alcohol. What do you observe? The difference in the levels of liquid column is more when the thistle funnel is dipped in glycerin, and least when it is dipped in alcohol. This is because the density of glycerin is the most, and that of alcohol is the least. Thus, we can conclude that the pressure at a point inside a liquid increases with increase in density of the liquid. To prove that pressure is same in all directions about a given point within the liquid, record the difference in the levels of liquid columns with the thistle funnel pointing vertically downward, vertically upward, and towards the sides of the tall cylinder. We observe that there is no change in the levels of the liquid columns. This proves that the pressure is same in all directions about a given point within the liquid.
Thank you. This is the topic. This was the video related to the law of liquid pressure. Now let me continue from the remaining topics related to the liquid pressure. Now we'll begin through this slide that's related with the factor affecting liquid pressure. You know, there are the different factors that is directly related to the liquid pressure, as we already discussed in the video also. That is density of the liquid, that is represented by d r rho. This symbol is called rho, this symbol is d. Both of these can be used to represent density, and density is the factor that directly affects the liquid pressure as in directly proportional relation. It means if density increases, the pressure also increases and vice versa. Second one is related with the depth. Depth, in other words, we can tell height also. If we are measuring in from the vertical downward position, we'll call height. From vertical from surface to the downward position, we'll call depth. So liquid pressure is directly proportional to the depth of the liquid also, and hence when height or depth of the liquid increases, pressure also increases and vice versa. As for example, if you open the tap of same volume at the top floor and ground floor, the vessel at the ground floor fills faster. That is the example related to the law of liquid, related to this condition, that is depth is directly proportional to the liquid pressure. Next one, acceleration due to gravity. You know, when there is the vertical downward motion, then direct effect, there will be the direct effect of acceleration due to gravity. And as soon as if there is the increase of acceleration due to gravity, the liquid pressure also increases. So these are the main three factors in which liquid pressure depends. They are density, depth, and acceleration due to gravity. Any questions related to this?
No, sir.
Okay, then I'm going to continue related to the other topics. Now I'm going to discuss about the consequences of the liquid pressure. What is the next topic? Consequences of the liquid pressure. The pressure exerted by the liquid increases with the depth, as it is directly proportional to the pressure exerted by the liquid that we already discussed just now. Similarly, a liquid finds its own level. Whether you drop or you put directly or partially, that doesn't matter. After filling a vessel, after putting into the vessel, after dropping into the vessel, it automatically finds its own level. Similarly, the pressure at any point in the liquid acts in all directions. Liquid doesn't act in a single direction or bidirection. It acts in all directions. It means when there is liquid, it exerts the pressure, the left direction, right direction, up direction, down direction, in all. So these are called the consequences of liquid pressure. Now, a question is related here. A question is asked here. This is related to the law of liquid pressure. I'm writing here, I'm showing here a question. If anybody's of you know, try to explain. Otherwise, I'll give the explanation or details about this question. Calculate the pressure exerted at the bottom of the vessel, which is full, and its height or depth of the liquid is 50 centimeter. A vessel consists of liquid up to the height of 50 centimeter. It means that is fill up. Then how can you calculate the pressure, liquid pressure over there? Just use the same formula. P equals to HdG. P we need to find as, that means height or depth of the liquid, that is given as 50 centimeter, and you have to convert that into the meter. Then you get 0.5 meter. Density of the liquid, if you don't know, then try to learn. In SI system, that is 1000 kg per meter cube, and in CGS system, it is 1 gram per centimeter cube. Note it down if you don't know. If in SI system, you need to note 1000 kg per meter cube, and CGS system it will be 1 gram per centimeter cube. Whether the question will be given or not, that doesn't matter, but you must know this value. Similar to acceleration due to gravity, that is always fixed, that is 9.8 meter per second square. Now we apply the formula related to the law of liquid pressure. P equals to as it is H, height or depth 0.5, density 1000, and acceleration due to gravity 9.8. Combining these all, multiplying these all, we get 4900, and then the SI unit related to the pressure is 4900 Pascal. In this way, we'll calculate the equation or find the value of liquid pressure by using this formula. Now, another question. A liquid density that is 0.8 gram per centimeter cube is half filled in a cylinder vessel of the height 2 meter. Calculate the pressure exerted at its bottom. Look at here. If water was given, then not necessary to given the density value. That is fixed. That we must know. But if other liquid is given, then there must be given density value. That is 0.8 gram per centimeter cube. Look here, density is given in gram per centimeter cube. I mean in CGS system. But height is given in meter. Height is given in meter. Whether you change all of these into the CGS system or into the SI system, but you could not mix together. Remember that. Just if you want to change CGS system into the SI system, then you need to multiply by 1000 for density. Okay. If you want to change SI system into CGS system, you need to multiply. So you need to divide by 1000. For example, look at here, the density of the liquid is given as 0.8 gram per centimeter cube. Then if you multiply it by 1000, then it goes to the kg per meter cube. To get the density, height is given, acceleration due to gravity you know already. By applying the same formula to that of previous, you can find it. Can you find now? Please try once. Have a look once and calculate yourself. Look at this slide one. Look at this slide once and ask me if you didn't get anything over here. Now, can you do it or not? Reply me as soon as possible.
Yes, sir.
Okay. Only Dilasa will do, or other also can.
Yes, sir. Sir.
Okay. All of you try and do this question as it is important from our examination point of view also. Okay. May I go further now? Or you will complete this at first? What to do? Should I wait for some time?
No, sir.
Okay, then I'm continuing to the next slide. Okay, write this question also. Note down on your copy. It's your homework. Calculate the pressure exerted at the bottom of the cubical vessel of the volume 125 centimeter cube, which is half filled with water. And then half filled with the water. What does it mean? Then height of the liquid column will be half of the pressure. Height of the liquid column will be half of the pressure. So it is called half filled. How can you do this? Anybody can reply me answer? We need to find pressure. For pressure, we need to know H, D, and G. Height, density, and acceleration due to gravity. Density and acceleration due to gravity, already we know. Just we know height. We need to know height. Just we need to know height. And for height, question has given volume. In which shaped body there? That is cubical. Cubical vessel there. Then if cubical vessel there, then if cubical vessel volume is given there, then how can you find length of that cubical vessel or height of that cubical vessel? What is the formula for finding the volume of cube? What is the formula to
L,
calculate the volume of the cube? Yes, once again,
L
anybody?
cube.
L cube. Very good. L cube, B cube, or H cube. Anyone you can write, because L, B, and H all will be same here. Being it is cubical shape. Being it is in cubical shape. So you'll get L or B or H by applying that formula. And after finding this, H, other already given by the question, H, if you found the H, then you must divide by that 2 to get the height of liquid column inside the vessel. Why? It is half filled. It is half filled. Vessel is half filled. So half of the height of the vessel will be equals to height of the liquid inside the vessel. Understood or not? If you found that multiplied with D and G, I'll get the value of pressure exerted by the liquid column into that vessel. Calculate it yourself. That's your homework. Now, we are going to start another major topic of this chapter that is related with pressure. That is Pascal's law. This especially we'll discuss about the 3 laws over here now before ending the chapter. They are Pascal's law, Archimedes principle, and law of rotation. Once again, Pascal's law, Archimedes principle, and law of rotation. Among them, the first one I want to begin now. That is related with Pascal's law. Let me begin for the Pascal's law. Pascal's law states that the pressure exerted by liquid enclosed in a vessel transmitted equally and perpendicularly to all directions. It means when there is pressure applied in a vessel or container which is closed, then that flows that transmitted perpendicularly and equally to all directions. That is the explanation related to the Pascal's law. Here I'm showing a figure in your presentation. Down, look at here, vessels there which is compactly closed, and we are applying the pressure by using the fingers in 2 opposite directions. As soon as we press, that flows perpendicular to all directions. So when we apply pressure at any point in a closed vessel or a container, that passes, that flows, that transmitted equally and perpendicularly to all directions. It means, suppose you have applied the pressure over here, from here, then it flows in this direction also, in this direction also, in this direction also, in this direction also, in this direction also. That is equally, magnitude will be also same, value will be also same. that doesn't makes difference with other value. This law was formulated by Blaise Pascal, who was born in 1623 in France. This law is applicable for both liquid as well as gaseous particle. The verification of the Pascal's law can be done by using a simple experiment as shown here. Just to take for another experiment you can do in your home also. Take a polythene bag, a small polythene bag, put certain volume of water inside that, and then close its mouth. Okay, then press from one side that close equally and perpendicular to all directions. That is the experiment related with Pascal's law. Practically also will verify when our school starts. For now, I'm going to discuss. I'm discussing this much only. If anybody getting confused about this, then you can ask me. Otherwise, I'm going to the further point. Now we are going to discuss instrument related to the Pascal's law. The first instrument that should be known, that should be understood related to the Pascal's law, that is called application of Pascal's law, that is hydraulic press. I'm going to discuss some points related to the hydraulic press. I have already told hydraulic press is an instrument or equipment based on Pascal's law. Hydraulic press is used to increase the applied force into the certain multiplicative value by small to the large extent. To create the hydraulic press, we need to use two or more pistons with a different cross-sectional area along with liquid like water or oil. The structure is shown in the picture. I'm showing here in this figure. This is the structure of hydraulic press. Here, F1 is the force applied. A1 is the area of cross-section of the input hydraulic press. Similarly, F2 is the force produced or effort produced. A2 is the area of cross-section of the hydraulic second piston of the hydraulic press. We'll apply the force over here, that is called input force, also called effort applied, and we'll get the force resultant force over here, the large area of cross section, and that gets connected through the liquid surface. Compressible character of the liquid. When you apply force, that gets transmitted, that produces the effect on this area of cross section, due to which liquid gets transferred, and that affects into the second piston, and hence it works. Before going to explanation about the hydraulic press, I'm going to discuss some more points related to this, and then I'll go for its structure. A structure is made as shown in the figure, as shown in the picture, just I shown you in the just few seconds ago, and the liquid is added into it. Then the piston of matching side are inserted in the opening, and openings are sealed. The openings are sealed in such a way that the piston are allowed to move freely, pressing the liquid. When the small piston is pressed, the pressure is distributed equally in the liquid, so larger piston will move upward. Now, hydraulic press is used to multiply the force. It means by applying the small force, if you want to make large amount of force to do some work in vertical, especially in vertically upward direction, that we call hydraulic press. That is the application of hydraulic press. It is based on the principle of Pascal's law. And Pascal's law explains that pressure exerted by the liquid in closed vessel. Look here, this hydraulic press is closed. in the piston P1 and piston P2 also. So being it is closed, we can apply. If this piston, both of these piston are closed, then pressure exerted over here in piston P1 and piston P2 are same or equal. So being they are equal, then we are using the concept that pressure applied, pressure produces at any part of the closed vessel or cylinder will be equal. By using this concept, we will prove the theoretical explanation, mathematical explanation, expression for hydraulic press. But due to the lack of time, only few uh, minute of time, few second of time remaining. So I may or may not explain about this whole topic. I'll try once. Look at here. This is piston P1, piston P2. Pressure exerted in both of the piston will be same. We'll assume that according to the Pascal law. And you know, yeah, P1 equal to F1 by A1. That is pressure 1. That is F1 by A1 in the across the piston P1. Similar pressure exerted in the piston 2. That is P2 will be equals to F2 by A2. According to the Pascal's law, pressure exerted at the piston P1 and pressure exerted at the piston P2 will be same. I have shown here also. And if we equate this, then force exerted at the piston P2 will be equals to A2 by A1 or F1 by A1 into A2. This is the required amount of pressure exerted at the piston P2. Thank you everyone for today's class. As I'm already signed out, another teacher have signed in my opinion. So thank you everyone for today. Being the lack of time, only few seconds remaining, so we make out any time. Have a good day. Goodbye for today. Meet you tomorrow. Bye bye.
Thank you, sir.